Hello and welcome to iBwave's webinar on the Big Game Instant Replay. The webinar will begin in about 2 minutes. Hello, I'd like to welcome everyone to the iBwave webinar on the Big Game Instant Replay. My name is Marie-Claire Charlton and I work in Marketing and Communications at iBwave. We're very excited to be with you today and presenting a new webinar format. Instead of focusing most of our time on presentations, we'll be using a little less than half of the session to present some background information on our topic, and then we're going to be dedicating the rest of the session to a dynamic panel discussion based on questions sent by you. We thank you for all of the questions you sent during registration for the webinar. Our first presentation, given by Chris Horrigan from Crown Castle, will cover the network at University of Phoenix Stadium and its surroundings and go over some of the challenges that Crown Castle faced while designing, implementing, and monitoring the network there. Then, Tormod Larsen will go over how his company, ExteNet, supported the demand for traffic around the stadium, including some of the key hotels for the big game. Finally, Jim Parker at AT&T will provide his team's network traffic results from pregame to postgame and give us some impressive stats that will definitely spark conversation. Joining our three speakers for the panel is Richard Barth from Sprint, and the panel will be moderated by iBwave's Dominique Gauthier. If you have a question for our panel, please type it into the questions box on the GoToWebinar control panel at any time. And if time permits, we can answer a few of these. If not, we'll be getting back to everyone after the webinar. For those who may have audio difficulties, we will try to speak as loudly and clearly as possible, but please make sure to check your audio settings on your computer or phone as you dial in. And we'll be recording today's webinar and sending the recording, as well as the slide deck, to everyone tomorrow. The recording will also be available on the iBwave website by tomorrow. And lastly, we'll be actively tweeting throughout the webinar, and we encourage you to join us. You can follow us at iBwave and use the hashtag iBwaveTalks to join the conversation. Please also feel free to ask your questions for the panelists via Twitter if you prefer. So our first speaker today hails from Crown Castle, where he's the Director of RF Engineering in the West region for their Small Cell Solutions Group. Here is Chris Horrigan.
Thank you, Marie-Claire, and good day, everyone. I'm Chris Horrigan, Engineering Director for Crown Castle Small Cell Solutions in the West region. I'd like to thank the folks at iBwave for inviting me to participate in this very informative presentation. I'm glad to be here. By way of introduction, I'd like to say that Crown Castle is widely known for our network of 40,000 plus towers, rooftops, and site solutions, but we're becoming better known over the last couple of years for our Small Cell Solutions division that supports more than 14,000 DAS and small cell nodes and 7,000 miles of fiber. We also have a significant and growing presence for neutral host systems at universities, theme parks, stadiums, resorts, and other hard-to-serve, high-traffic and capacity-constrained locations. In the outdoor DAS and small cell arena, we offer compact, low-profile solutions for areas needing improved coverage and increased capacity. Hard to zone, hard to build, hard to cover areas are our specialties. We put our national presence and local expertise to work for you to offer a full line of site development services, making the process of finding, building, and maintaining traditional cell sites or small cell sites as easy as possible. And Crown Castle operates a fully staffed, state-of-the-art network operations center that monitors all of our sites around the clock, 7 days a week, prepared to generate trouble tickets and dispatch our well-equipped and well-trained field operations technicians to maintain high levels for system availability. In this aerial overview of the Glendale Sports Complex, I'll talk to you some of the venues. At the bottom of the page, you see the Westgate Entertainment District. That is a mixed-use regional destination for shopping, dining, and entertainment. Crown Castle constructed, commissioned, and optimized a new neutral host ODAS system that included 4 light poles, 1 pedestrian bridge, and 14 rooftop node locations, involving 53 new antennas and 7,000 linear feet of new fiber for AT&T, T-Mobile, and Verizon. At the Gila River Arena, which is home to the NHL Phoenix Coyotes hockey team, Crown built a new neutral host IDAS involving a new 1,500 square foot head end on site, 303 new remote antenna locations, and 83,000 linear feet of fiber and coax cable. This project was delivered ahead of schedule and in time for the 2014 NHL season. At the Renaissance Glendale Hotel, Crown constructed, commissioned, and optimized a new neutral host IDAS, including 257 new remote antenna locations and 71,000 linear feet of fiber and RF cabling in the 12-story hotel, covering 320 guest rooms and 100,000 square feet of convention and meeting space for AT&T and Verizon. This project was accomplished during limited daytime working hours with minimal disruption to guests and hotel operations. At the University of Phoenix Stadium, home to the NFL Arizona Cardinals, the stadium neutral host DAS that was already there evolved through the 2014 NFL season from the existing 1-layer 25-zone 186 remote antenna system to a 2-layer 48-zone 228 remote antenna location system. A neutral host IDAS serving AT&T, Sprint, T-Mobile, and Verizon that included the addition of over 150,000 linear feet of cable and fiber. Sectorization for the wireless operators varied from 18 sectors up to 48 sectors. Construction, commissioning, and optimization were completed during the regular football season in order to have the facility ready for the last regular season games, as well as the postseason Fiesta Bowl, Pro Bowl, and the big game. To provide system support for outdoor activities near the stadium, Crown constructed, commissioned, and optimized 21 new ODAS sites, including 13 custom parking lot poles, 8 custom building-mounted sites, 32 new antennas, 3,500 linear feet of secondary conduit, 5,000 linear feet of fiber optic cable, in time for the Pro Bowl and the big game. Not shown on this page, away from the complex, we have another site that we use in order to provide sufficient space to house a large number of base station radios, bringing capacity to the complex. Crown Castle constructed a brand new 7,500 square foot hub facility built on Crown Castle owned land approximately 4 miles from the Glendale Sports Complex. This hub houses AT&T, T-Mobile, and Verizon base station gear and the DAS head-end equipment supporting the Stadium ODAS, the Renaissance IDAS, and the Westgate ODAS, connected to the complex by 30,000 linear feet of a new 864 count fiber optic cable located underground in the city of Glendale public right-of-way. In planning for the Gila River Arena, Renaissance Hotel, stadium parking lots, and the Westgate Entertainment District systems, it was necessary to take into account the surrounding macro cell and cell on wheels integration and dominance, the aesthetic issues that would be involved to hide or stealth antennas and DAS equipment, handoff planning between the macros and the ODAS systems, the number of sectors, capacity planning required for parking lot nodes during the big game tailgate in coordination with expected macro and cow coverage, and of course meeting the RF design criteria for all of the wireless operators, primarily SINR, RSRP, dominant server, and average downlink throughput. For the stadium, the neutral host design process had to accommodate wireless service providers with varying timelines for completion of design approval and build schedules. The technologies that were deployed were CDMA, EVDO, UMTS, GSM, LTE, and of course LTE for everyone. And these technologies were deployed in the 700, cellular, PCS, and AWS bands. Crown developed the neutral host link budgets to share the available amplifier power among different operators equitably for varying channelization plans over the previously mentioned frequency bands and technologies. The DAS had to be designed to provide signal strengths that were dominant by 8 to 10 dB over the signals coming into the building from outside macros and cows. The seating capacity and configuration by section, as shown, with additional temporary seats for the big game, had to be divided into dominant serving zones based on number of seats and seats per sector carrier. With regards to the practicalities of installation, it was necessary for us to work through multiple versions of the physical layout with the venue owner in order to find antenna and remote amplifier locations that would meet the required numbers of zones per sector. Additionally, it was necessary to establish the pathways to serve those locations for fiber, power, and RF cabling. Due to the complexity of the stadium environment, we performed multiple iterations of the design in iBwave as the model was refined through CW testing in order to optimize the selection of antennas and their locations that would provide maximum sectorization and isolation zone to zone. Later in the process, Galtronics introduced their ExteNet line of panel antennas that provided an excellent combination of vertical and horizontal beam widths across all bands, and they were instrumental in the strong performance of the system. Design work began in earnest in the latter part of 2013 with near final revisions and equipment ordering occurring in early summer of 2014. It is noteworthy to mention that client contracts and landlord leases were still being finalized concurrently. The upgrade of the Cardinal Stadium occurred throughout the 2014 regular football season for all the wireless service providers and required moving existing equipment, increasing the floor space, power, and heating, ventilation, and air conditioning capacity of the 3 hubs that were located in the stadium, improving the intermediate distribution facilities throughout the stadium, and adding a great deal of conduit. The operators increased their sector counts from 25 to 48, 33 to 38, 12 to 30, and 12 sectors to 18. We also had to place 6 miles of fiber in the public right-of-way to serve as the backbone for all the big game projects from the newly built Crown Hub off-site. The Orangewood Hub, as we refer to it, was built in the summer, 7,500 square feet to support the enormous network capacity being brought to the complex. Crown was fortunate to team up with several deployment partners who did an outstanding job of working odd hours on accelerated schedules in multiple venues, doing whatever was necessary to make us all successful. Challenges of optimization. We found that with multiple carriers using multiple vendors and sometimes sub-vendors, that the data collection process for testing purposes was not always consistent. As an example, there were occasions when data was being collected unbeknownst to Crown while the system was being worked on, generating confusion when the data showed poor or misleading results. Communication and coordination improved as time went on. Since Crown Castle served as the broker of the system configuration, we assigned dedicated Crown engineers to each operator that work together to provide the best possible performance for each client through the common and shared elements of the system. The optimization of the antennas required a very methodical approach, with Crown Castle maintaining a log of antenna positions, of each antenna's position, and performing multiple data collection iterations to evaluate incremental changes and their impact by operator to key coverage parameters. Traffic balancing between frequency bands was a key optimization point critical to the wireless operators that could only be well measured when the system was loaded up on game days. The few opportunities to refine the balance between high and low band coverage brought increased focus and pressure to those days. For game day, the venue staffing on game day was a combination of employees and contractors representing deployment, RF engineering, and operations. At the stadium, we had 12 folks. At Gila River, we had 3. At the hotel, there were a couple of people. At Westgate Mall, we had 3 people. Over at the Orangewood Hub, we had 6. And at the command center for one of the wireless operators. We had 2 RF engineers for a total of about 28 people. Due to the preparedness and prior planning, there were no major incidents and very few minor alarms. And here's a shot of the day after the big game. Thank you for your time.
Thank you, Chris. Our second presenter is Tormod Larsen, CTO at ExteNet, who brings with him vast experience in the development, building, and managing numerous network systems throughout the United States. Over to you, Tormod.
Thank you, Mary Claire. My name is Tormod Larsen. I'm the CTO for ExteNet Systems. ExteNet Systems is the largest independent provider of distributed networks in North America. Our sole focus is to design, build, own, and operate indoor and outdoor DAS and small cell networks. ExteNet's been involved with the big game for a number of years, including the Super Bowl in Dallas, Indianapolis, New Orleans, New York, in addition to a number of other sports venues across U.S. and Canada. And what we've seen over the last few years in being involved is an increased focus on also areas beyond the stadium itself, including the hospitality venues close by, the general infrastructure in that area, and more specifically for the Super Bowl, it's becoming an event that lasts significantly longer than the 4 hours when the game is on, and it's involving basically the entire area where the event is held. I think Phoenix is a good example. This year they anticipated that it was about 1 million people visiting Phoenix during the big game weekend. They also had a 12-block area downtown Phoenix that was named the Super Bowl Central. There was a lot of activity during the days leading up to the Super Bowl, and obviously also during the Super Bowl itself. And according to AT&T, during the game itself, more than 2/3 of the traffic actually was reported outside the stadium itself. So we'll review a few examples of these type of venues through the presentation today. And obviously, the fans are important, and as we talked about, I think it was about 70,000 people attending the game as fans. But there's also a lot of other activities around that in the area, and an example of people that are involved in that is obviously Roger Goodell. And in order for him to not be completely deflated, and him with other visitors, they have to eat, drink, sleep, and entertain. And one example of our venues where those type of activities are going on was the Phoenix Sheraton, downtown Phoenix. Phoenix Sheraton was one of the several designated official NFL hotels, where there's a lot of activities, a lot of events held. And it's also the largest hotel in Arizona with a little bit over 1,000 rooms and 31 floors. It's actually also a co-owned facility between Sheraton and the city of Phoenix. ExteNet put in a multi-carrier DAS in this facility. We utilized solid active DAS equipment, put in about 436 antennas and close to 60,000 feet of cabling to be able to provide service for all of the carriers. The venue agreement with Sheraton and also with the city was put in place in March of 2014. The carrier agreements, we were able to execute them in the time frame between September and November of 2014, and we went live with the network in January of 2015. So you can see it was a pretty compressed time schedule and a lot of coordination to make that happen. Another similar venue that we were involved in was the Phoenix Westin, a little smaller venue, about 242 rooms, 26 floors, state-of-the-art facility, another NFL hotel, also located close to the Super Bowl Central downtown Phoenix, and also close to the Arizona State University campus. Same thing, we put in a multi-carrier DAS solution. In this case, we used TE connectivity DAS equipment. Actually, the time frame here was a little bit tighter, but smaller network also was able to finish it up a little bit sooner. So the venue agreement, we're able to put that in place in June of 2014. We had a carrier agreement in place in October of 2014 and was actually operational just before Christmas of 2014. This network was around 100 antennas and about 10,000 feet of cabling. So, like I said, obviously a lot of the focus is on the fans, but what about the players? And what was on the mind of Richard Sherman? Obviously, the big game was important to him, but he had some events also happening from a personal perspective. His girlfriend was pregnant, and there were obviously a lot of discussion about whether if it would be able to play the game and how the timing would work out relative to that. Fortunately, he was able to play the game, and part of it was that his girlfriend was actually at the hospital about 3.7 miles away from the stadium, and his son was born a few days later. This is one of the Banner Medical Center facilities, actually Banner Estrella Medical Center, and this illustrates kind of the importance also of infrastructure beyond kind of the traditional facilities and areas. ExteNet have built out a number of the Banner Health properties. It's about 6.5 million square feet spread over 12 various facilities. Same thing, multi-carrier solution, obviously focused on healthcare grade quality, and it's also focused on events, because these type of facilities will also see spikes in traffic and need to be designed to accommodate that. The last thing is, what was on the mind of ExteNet as we were, supporting these various facilities. And from a NOC perspective, when you're going through events like this, like I said, we've done this for a number of years now. One of the keys is preparation. Develop event operational plans, practice the plans, really making sure that everybody is aware of the network topology and how they work, and then also test and benchmark the performance so you know what to expect. So you're not only looking for alarms, but you're also looking for trends, which kind of tying into the execution. Like Chris mentioned, having field staff ready and in market is important, but also from a NOC perspective, closely and proactively monitor the network and being able to see trends and see problems before they actually occur. And then, along those lines, also have spare parts if you have problems, have them ready available. And then communication, which always is key. Pre-event, talk about the expectation, how you're going to deal with certain things, making sure everybody's on board with that. And then during the event, frequent communication, good status, clear communication in terms of what's going on, because there's obviously a lot of moving parts, a lot of things that's happening during that compressed time. And then post-event, do a lesson learned, communicate, and see how we could do things better. So, the bottom line is, obviously the stadium and the solutions here are critical, but also having network infrastructure and solutions that are supporting the needs outside the stadium is critical for a successful event as well. With that said, appreciate your time and thank you very much.
Thank you, Tormod. So our final presenter today is Jim Parker, Senior Manager at AT&T Services. Based in Dallas, Jim is responsible for marketing AT&T's in-building wireless solutions, including neutral host DAS, small cells, and Wi-Fi. Over to you, Jim.
All right. Well, thank you very much, and I appreciate the opportunity to participate on the webinar. Well, as you can imagine, AT&T has a special events team that analyzes and models the traffic demands on our network. They also take into account all of the ancillary events such as press conferences, media events, and the like. So prior to the big game, the DAS at the Glendale Football Stadium and venues throughout the greater Phoenix area have been updated. The upgraded DAS at the stadium will provide 3 times the LTE capacity as compared to the end of the 2013 football season. We've also upgraded or installed new DAS at 13 nearby locations, including hotels, sports arenas, convention centers, and other venues where fans are likely to be. And then in addition, AT&T has deployed 10 cell on wheels and 24 new or upgraded cell sites throughout the area. Television viewership set an all-time record with over 114 million viewers. Cardinal Stadium capacity is 75,000 seats, and it was packed with fans and members of the media. As Chris had explained, there's actually 2 systems deployed at the stadium, an indoor DAS using equipment from TE Connectivity and an outdoor DAS using equipment from CommScope. The indoor DAS utilizes 48 sectors to cover the stadium, and all the leading wireless carriers utilize the same DAS infrastructure in order to provide service to their customers. Then the outdoor DAS is used at the stadium parking lot with antennas placed in the vents around the stadium and poles in the parking lot and tailgate areas. An outdoor DAS was also installed at the Westgate Entertainment District, where many of the pre- and post-game activities were held. Well, the results are in. The mobile data traffic consumed at the game set an all-time record on AT&T's network. In-venue data consumed was 696 gig, which is equivalent to 1.9 million social media posts with photographs. When looking at the numbers from both the in-stadium DAS network and the outdoor stadium DAS network servicing the parking lot areas, we did more than 1.7 terabytes of data, which is equivalent to 4.8 million social media posts with photographs. Fans uploaded and downloaded the most data on the in-venue network from the hours from 3 to 4 p.m. Mountain, which is the hour in which most fans started to file into the stadium. During this hour, 125 gig crossed their in-stadium network. Compared against the 2011 game, total data usage on the in-stadium network increased from 177 gig to 696 gig, which is close to a 300% increase. So, well, thank you again for your time.
Thank you very much, Jim. I think we now have a good understanding of the immense amount of work that went into this network, and so we're going to move on to our panel discussion. Joining our panel is Richard Barth, Manager of RF Engineering for the National In-Building Team at Sprint. Based in Atlanta, Richard's responsibilities include public venue and enterprise in-building engineering using DAS, small cells, and Wi-Fi. Moderating the panel today is iBwave's CTO, Dominique Gauthier. Based in Montreal, Canada, Dominique oversees all aspects of product development with a focus on providing clients with high-quality in-building wireless solutions. We have many questions to get to, so without further ado, I'll pass the mic over to Dominique and our panel.
Thank you, Marie-Claire, and welcome everybody to this group discussion. Before we start, I'd like to thank all attendees who took the time to submit questions during the registration process of the webinar. And also today, we've got many of you who have already posted questions into the question box. So in preparation to this panel, I tried to create categories of questions that I will assign to some of the panelists so that we get the most out of this group discussion. So let's start with the first question that I would like to direct to Richard. Many people asked, how do operators go about dimensioning a DAS of this magnitude? So most importantly, people would like to know, how do you define what is your target user experience in terms of downlink and uplink data rates, as well as many people would like to know how how many sectors and how did you get to the number of sectors that was necessary to satisfy the demand, as well as the different frequencies and technologies that you decided to broadcast in such a venue.
Sounds good. So at Sprint, we found that the average user tends to consume about 3 to 4 times the amount of data that they would normally consume in the busy hour, and it does depend on the type of event that is taking place. In order to determine the sector count for any venue, Sprint uses a capacity calculator that takes into account inputs like the stadium seating count, Sprint's market share in the market, the handset penetration rate by band, the number of LTE carriers per band, average level throughputs that are achievable per band, the minimum desired UE throughput, the estimated tonnage that we believe each subscriber will use, and the number of years of planned growth that we're trying to achieve in the venue. So getting the capacity plan correct is really the first step to ensuring a successful user experience.
Good. So, so 3 times the amount of data that a user consumes on a general basis. So that's quite a different behavior. Jim, anything you'd like to add with regards to how AT&T goes about defining the quantity of sectors and planning for such dimensioning exercise at AT&T?
Well, for AT&T, the in-stadium DAS was configured for 38 sectors. This is the first venue where we have installed capacity to support 4 LTE carriers. As we found, LTE users consume, right about twice the mobile data traffic on our overall network. So we wanted to ensure that the network was up to the challenge. In addition to the 4 LTE carriers with MIMO, we had 2 UMTS carriers installed in the in-venue DAS as well as the outdoor DAS. And then, looking back at the event, we had a green performance on both the UMTS and LTE throughout the entire event.
Interesting. Well, thank you both Jim and Richard. The second question is, I'm going to direct this question to all panelists, and let me start with Chris. This was most likely that was probably the most popular question that was submitted prior to the webinar. People are interested to hear what were the biggest challenges that you faced through this deployment and this massive amount of sites and antennas to roll out, and all the quantity of cable that you had to lay out. And what lessons have you learned from this past project?
Thank you, Dominique. Yes, aside from the technical issues that are involved with the high density of RF, it's really a very large and complex project management exercise. On the relationship side, it required commitment from our customers as well as our landlords. The sooner we could get that, the better. Even when some of that commitment was not always there, designs were moving forward and being revised. At some point, we had to get sufficient commitment on the design to be able to order equipment due to lead times and delivery schedules. So, while I mentioned in the presentation that concurrently there were times when we were still finalizing contracts and finalizing leases with landlords. Certainly, a key tenet to project management is to communicate early and often. throughout the entire duration of the project, from early days to last minute, it was necessary to try to keep those channels clear and open. We found that choosing good partners makes a huge difference. We had contractors working for us that I mentioned in the presentation that did an excellent job of supporting us on multiple jobs, multiple parallel efforts across multiple venues. It worked out very well. And of course, always to instill in everyone, even when they're working long hours and 7 days a week, and exhaustion and is starting to set in, we have to continue to maintain that sense of urgency. There was such an enormous amount of work that had to be accomplished that there was no opportunity for a real let-up until the game was over with.
Good. Well, thank you, Chris. I can imagine you had little time to breathe and relax. Tormod, what are the challenges that you would like to highlight to this panel?
No, I think what Chris said, kind of echo a lot of that. Obviously, we've been involved in a number of these type of projects, and we kind of know what we're up to, but timing is always critical. Being able to get going, and we know it'll be compressed timelines. There are a lot of stakeholders, and all of the stakeholders, either being the carriers or the venues or the city, it's a lot of things happening in that area and around it. So, again, the timing aspect, the priority aspect, making sure that able to drive through things. Same thing with access, right? When you're getting closer to the game, everything becoming so much more difficult just because of all the restrictions and all that. So, yeah, you need to be done kind of earlier than maybe sometimes you would think. The last part is, with these type of events, it's very difficult to predict what will happen. So, you could do a lot of testing, you could do a lot of things, but, it's very difficult to emulate the environment that will happen during these events. So in some instances, you just need to plan for the worst and kind of put on belt and suspenders to make sure that you are in good shape. And I think, what Jim showed earlier in terms of the growth that and data traffic that we've seen on these networks over the years, being a little bit, I don't know if we would call it conservative or aggressive in terms of what you would expect could happen, normally pays off in instances like this.
Good. And Tormod, would you say that in most cases it's coordination that is the biggest challenge rather than the technical issues that you run into?
Yeah, coordination and again, just the fact that you have timelines that you just need to stay to, right? It's Super Bowl going to happen on whatever date that is, right? It's not like you could take a few more days, or so you just need to be aware that that's the situation. And in some instances, I think Chris kind of mentioned it, is make sure that you make those decisions, and sometimes you just need to drive through and say this is the way it will be, and move on to make sure that you're ready for that big day.
Yes, very true. There's no such thing as to postponing the date of the big game, so you don't have that power. Thank you, Tormod. Jim, how about AT&T? What would be the biggest challenges that you're facing into such a big event, and also the lessons you've learned over the past years?
Well, at AT&T, we have seen a tremendous growth in mobile data traffic, with over 100,000% growth over the last 8 years. So the biggest challenge is to dimension the system to meet the traffic demands of today and into the future, which is a tough design goal when you have 100,000% growth rate. But our design goals are to design the system to meet the needs and requirements over the next 3 years. For lessons learned, all the hard work has paid off. The system performed well without incident. And as we've learned from big games in the past, you can't rely on stable power for mission-critical applications. So you have to plan for the unexpected.
Good. Thank you, Jim. Richard, how about you? How what would be the biggest challenges from a Sprint perspective?
Yeah, I think I'll just echo everybody else's comments. You know, there's a tremendous amount of work that has to take place to make all this happen. So implementing early and planning for unforeseen events will help guarantee a successful deployment. We always find that we spend more time planning, you know, balancing the LTE load, optimizing the downlink, the uplink, and working out any intermod or other issues that may arise even after the DAS is constructed. From an engineering perspective, you know, maximizing the spectral efficiency of the LTE carrier continues to challenge us in any stadium environment. But obviously, one thing that we did learn was that the new LTE or the larger LTE channels perform very well in these difficult SINAR environments. So I think that's going to be a continued theme moving forward. Is bigger channel sizes work better. We know that everyone's adding as much LTE capacity as possible, so I think that the challenge really remains maximizing throughput of each LTE carrier that we deploy.
Good. So Richard, when you talk about larger channels, what was the bandwidth of those channels?
Well, we're seeing some 20 megs now, and then with additional LTE advanced features like carrier aggregation, we'll see 20, 40, and even 60 megahertz channels coming in the future on LTE.
Okay. Good. Well, thank you. This is a question we just received live as we speak. Good. Well, thank you, gentlemen. So let's move on to the third question. And here we've got a broad variety of questions. Many were technical. Some are about the economics of such projects, and others about the challenges to deploy and to deliver on time. So next question goes to Tormod. Many people are interested to hear how systems like that get funded. So who pays for it at the end of the day?
So, you know, with our model, ExteNet will fund the build, and then we'll work with the various carriers based on their situation, and they will obviously pay us a combination of what we call non-recurring charges and recurring charges for both funding of the network, but also the operational aspects of the network. So from that perspective, we are the company that are funding it, and then working with the various stakeholders to, you know, again, based on their situation, to make sure that they can get on the networks.
Okay. So basically, at the end of the day, you end up being an operator of operators.
Correct.
Okay. Chris, were you applying a very similar funding model for the stadium and the surroundings projects that you presented to us?
Yes, we certainly were. It's a combination of there is certainly some capital that's funded by the operators up front, but it doesn't cover the entire cost of the system construction. So Crown sees to it that the system is built. Some of those costs are offset up front, and then ultimately over the course of the contracts, you could argue that the customer ultimately pays for it.
Okay, excellent. So next, we're going to move on to the next question. So I'm going to ask Chris and Tormod to stay around. We heard Jim and Richard telling us about how they go about dimensioning and figuring out how many sectors, what technologies will be needed in each of the venues. Ultimately, you receive the requirements from all the operators, and you need to satisfy various operators with various demand for sectors and for zones. So how do you go about managing these technical requirements? So first, on the technical level, so you probably have requirements to satisfy with regards to PIB, passive intermod. You have different KPIs to satisfy, perhaps for technology and in terms of data rates or SNR performance. So maybe let's start with these technical aspects. So Tormod, could you tell us how you you manage all these various and diversified requirements that you're being provided?
Sure. I think, first of all, again, been doing this for a while, you kind of have to embrace the fact that you will have disparate requirements. Things will change through the process. So we always looked at, when we design and build these networks, to make sure that they're flexible, they're scalable, and they're transparent. And with transparency, we're looking at, that the individual carriers could have somewhat of a different network configuration, despite that they are running over the same network. So, for example, they could have different sector counts, they have different frequency bands that they are operating, and they could have different KPIs in general, throughout the network and based on the technologies that they are deploying. So part of the strategy there and the philosophy that we deploy is basically breaking the network down in a backbone. That shared infrastructure is its fiber optic cable, antennas, the coaxial cable, and so forth. And like you mentioned, passive intermod, obviously the requirement for that, we typically will use the anchor tenant, or in cases where we have multiple carriers that are signing on at the same time, use the more stringent requirements. What we're also seeing for passive intermod specifically, it kind of developed industry standards for that as well, so it's a little bit easier to kind of accommodate that. And then we have the carrier-specific elements that are determined by the electronics or the DAS equipment or small cell equipment that will ride on that backbone. And that's where we could do some of the tailoring of services for the various carriers and how they provide their service within the venue. And that way, we have some flexibility, carriers have it as well, and again, accommodate those goals that I mentioned earlier.
Okay, thank you, Tormod. Anything you'd like to add, Chris?
No, it's pretty much the same methodology. Try to identify the broadest common denominators. Try to understand, the ultimate scope of the system to accommodate everyone, and make it so.
Good. So earlier we talked about the importance of coordination. So in your, from your perspective, Chris, how do you see, could you tell us more how these coordination meetings take place? Because I understand there are many players involved, there are the operators, you probably have partners who do some work for you, so that's a lot of people to manage and a lot of activities to make sure that are on track. So how, could you tell us more about how the coordination meetings take place with operators? Is it one meeting with all operators in the same room, or you have several meetings or individual meetings with each of them?
From about a year before the big game, we started engaging with the operators, and all the way through the design process, ultimately the deployment process. As we drew closer to the big game, and typically all the calls and meetings were with each operator individually. But as we approached the big game, the calls went from a maybe twice monthly basis to a weekly basis to a couple of times a week basis. Toward the end, there were actually calls occurring twice a day, every day, with some of the operators to maintain focus on specific technical issues or optimization challenges. Same thing with the deployment side. We had weekly calls with our partners to coordinate activities there. I know in the last month or so, the NFL actually started pulling everybody together, all the wireless operators as well as Crown and probably ExteNet, to talk through what was going on, what needed to happen, make sure everybody was on the same page.
Okay, well, thank you, Chris. Let's move on to the last question I had prepared for this group discussion, and then if time permits, we're going to take a few more questions from the audience. So last question will go to Jim and Richard, who represent operators. So over the next 5 years, how do you see networks or systems of that nature evolving? So based on the past, so can you tell us a little bit about how quickly you had to augment capacity in such venues over the past, let's say, 5 years? And I think some of you mentioned already, as part of your planning techniques, you're dimensioning the system to satisfy a certain, well, demand for traffic for a certain number of years. And then if you were to have a look into your crystal ball, what do you think a system at the same stadium would look like 5 years from now? So Richard, would you like to give it a shot at this convoluted question?
Sure. So I'll try to touch on the first couple points there, and then I'll give you an overall view of where I think things are headed. You know, as new bands are deployed, it's always very difficult to keep up with adding additional bands. Obviously, at Sprint, we have a very deep spectrum position in our 2.5 band, so that's going to be our way in which we deploy capacity in the years to come. So we're going to take full advantage of that asset that we have. We do plan 3 years out. So, you know, we try to make sure that we try not to have to touch these. It's, from my perspective, it's easier to add frequencies from an LTE carrier perspective than it is to add sectors. So anytime we can do something without having to physically touch the system, it's going to be a benefit for us, and typically a cost savings. But with regards to over the next 5 years, you know, I expect to see the stadium designs continue to evolve. I think we're going to see the increase for LTE capacity is going to continue to skyrocket. I believe that features like I believe Wi-Fi and then features like carrier aggregation will play an important role in satisfying the increased data demands. I think we're going to continue to see some advancements in DAS, Wi-Fi, and small cell products that get injected into the marketplace. I think these products will not only enhance performance, but it will help us to reduce installation time and cost. I think over the next 5 years we'll see services like voice over LTE and voice over Wi-Fi. They should become firmly rooted into the network. Lastly, I expect to see advancements and increased interoperability between LTE and Wi-Fi offerings from a mobility management perspective. So, you know, if the past is any indication of the future, I think the next 5 years should be very interesting.
Good. Well, I think I agree with you on this one, Richard. Jim, how about, so what's your view on this question over the next 5 years? How do you see these networks evolve for stadium environments and the like?
You know, this is what is so exciting about the wireless industry. There's constant change. You can never rest on your laurels. I mean, here we're looking at deploying in-building wireless systems that provide support for immense capacity, as demonstrated for just this one event. And you know, like for instance, you know, there's several industry initiatives that may very well alter how we deploy systems in large public venues going forward, such as license-assisted access, which will allow us to aggregate both licensed and unlicensed spectrum in order to provide much higher data rates and greater security to our customers. AT&T, we're in the process of rolling out carrier aggregation, which is part of LTE Advanced, which will provide greater capacity and the potential for higher data rates, along with rolling out carrier aggregation as part of the Voice over LTE initiative, supporting high-def voice. So you no longer have to go back to your landline to get high-quality service. With high-def voice, it has echo cancellation, noise reduction, and so the overall user experience will be much better. And then in addition, and this is an ideal application for large public venues, is LTE multicast. It results in more efficient use of network resources. So instead of everyone having to individually transmit and receive information back and forth, we could effectively broadcast information. So within a venue, they could have multiple channels to where the fans could log in and see the event from their handheld device right there at the venue. So there's a lot of exciting changes, and we haven't even talked about 5G. I mean, 5G is still being the specifics are still being identified, but there's a lot of legs left with the LTE.
Interesting. Well, thank you, Jim. Thank you, Richard, and also Chris and Tormod. This was quite an interesting group discussion. Marie-Claire, do we have time for more questions that we just received from the participants?
I think we have time for about 2 more questions. So.
Okay. Okay. So I think there was many questions regarding the antennas that were used in the stadium. So I guess most likely the question would go to Chris. Some people are guessing that you use apparently a new model of antenna, 30 by 30 degree horizontal and vertical beam width in the stadium. So could you please confirm if that's the case, and also other questions related to the importance of or the role antennas play into controlling sector overlap and making sure that you've got optimal sector throughput to minimize the interference between when you have so many sectors in the stadium. So could you please share a little bit of info on this with us?
Well, to the first point about the antennas, yes, that I mentioned that in the presentation, that we used made great use of a new panel from Galtronics that helped to control that RF pattern and minimize overlap and achieve best SINR.
Okay.
I didn't quite follow the second part of the question.
The second part of the question is related to how important is it when you do when you have a high sector count like in a stadium, how important it is to select the right type of antenna to minimize sector overlap?
It is enormously important. Yeah, you just can't get there without proper antenna technology.
Okay.
It's such a challenge. It's such a high density of radiation points.
Yeah. So I guess you probably have a few alternatives in your toolbox to choose from, depending on the sector count and the morphology of the stadium.
That's exactly right.
Yep. Okay. Good. Another question related. I guess some of the participants got attracted by some of the pictures that both Chris and Tormod have displayed. A question related to. So let me read it to you. For outdoor DAS antenna mounted behind ventilation vents, isn't there pattern distortion, or are the vents non-metallic?
The vents, I think, were originally metallic, and we replaced them with a custom solution that is RF transparent.
Okay. Okay, good. Well, thank you, Chris, for your contribution to these last questions. I know we have many more questions that we didn't take the time to address today, but for sure we're going to respond to each of you privately, and as much as possible provide a educated answer to your questions.
Thank you, Dominic. So we're pretty much out of time for this session, and I'd like to thank everyone who joined us and for your questions and tweets. To continue the conversation, I'll start a thread on our LinkedIn group, the iBwave user group. If you're not a member yet, I encourage you to join us. And if you think of a question after the webinar, you can go and type it in there. Any questions that were posted on the GoToWebinar questions panel, as Dominic mentioned, will be responded to via email. You can look for a recording and the slide deck from today's presentation in your inbox within the next couple of days. Thank you again to our presenters and panelists, and thanks to all of you for taking the time to join us today. Have a great day. I will now disconnect the call.